Good morning, students. We'll start with the today's lecture. Okay, this is lecture 52. Already we have seen the concept of state variable, and how to obtain the state model of the electrical system. Already we have seen, and also we have started with solution of state equations. So there are two types of state equations: homogeneous equation and non-homogeneous equation. And the solution of both the homogeneous equation and non-homogeneous equation numericals we have started. Right? Okay, today we will continue with that. Few numericals on solution of state equations, maybe homogeneous equation or non-homogeneous equation. Then last topic, that is transfer function model, transfer function from the state model. Yes, we have the state model. State model consists of both the state equation as well as the output equation, right? We have seen how to obtain the state model of the given electrical system, and from this state model how to obtain the transfer function. That is the last topic of this chapter. We will wind up this chapter today, right? Okay, next topic is transfer function from the state model and numericals based on that. If any doubts are there in between, please unmute yourself and talk to me so that I can clarify your doubts, right, immediately. Okay, consider the state equation. It is given. So it is x1 dot means dx1 by dt, dx2 by dt, and this is the state equation, means x1 dot, x2 dot, like that, right? So it is of the form, how it is? Just observe here, ax plus bu. So ax plus bu. Is it fine? Ax plus bu, right? This is the state equation, right? X dot equal to ax plus bu. X dot is equal to ax plus bu. This is vector a, this is state vector x, this is vector b, and this is the input u of t. Is it fine? Okay, it is asked to find out the state transition matrix. In the previous class we know how to find out the state transition matrix. So the state transition matrix, so we'll solve it. Solution: the state transition matrix phi of t, it is nothing but e power at, right? One and the same, e power at. And we know the formula for that. What is that? Laplace inverse of si minus a whole inverse. So Laplace inverse of si minus a, si minus a whole inverse, right? So first we'll find out si minus a, right? Si minus a. So I is the identity matrix. Its order is same as that of matrix A. Matrix A, at the order of the matrix A is 2 cross 2. So the identity matrix should be 2 cross 2. So we have to multiply S for that. So let me write S and I will multiply identity with identity matrix, and I will write that matrix directly. You can observe here 1 into S. S 0 0 S into 1 S. So 1 1 will become, right, 1 0 0 1. So I am multiplying S because S into I, right? This is S into I minus the vector A. Vector A is 0 1 minus 2 minus 3. 0 1 minus 2 minus 3. So subtraction of vectors, you know, S minus 0 is S. 0 minus 1, it is minus 1. 0 minus of minus 2, it is plus 2. S minus into minus means plus. S plus 3. So this is Si minus A, we got it. Next, it is asked to calculate Si minus a whole inverse. Then we have to take Laplace inverse, right? First, we will find out Si minus a whole inverse. So we know the formula Si minus a whole inverse. How to obtain the inverse of the given matrix? The adjoint of the matrix, given matrix Si minus a divided by the determinant of the matrix Si minus a. So first we will find out adjoint, then we will find out the determinant of the given matrix, then we will obtain the inverse of the matrix. So first we will find out adjoint of S minus a. Let me write it here. Adjoint of S minus a. Si minus a, sorry. So it is 2 cross 2 matrix Si minus a. So interchange the diagonal elements. So S plus 3 will come here, S will come here. Interchange the diagonal elements S plus 3 and S, and change the sign of the other elements. Minus 1 means it is plus 1. So it is plus 2 means minus 2, right? So thus hence we obtain the adjoint of the given matrix. You know that, right? So interchange the diagonal elements and change the sign of the other elements. This is adjoint of A. Then we will find out the determinant of the matrix Si minus A. Determinant of the matrix Si minus A. So multiply S into S plus 3. S into S plus 3 minus of 2 into minus 1. Minus of 2 into minus 1. So 2 into minus 1. Is it fine? So S square plus 3S minus into minus, it is plus 2 and 2, right? Okay, next we'll obtain Si minus A whole inverse. Si minus A whole inverse. So it is 1 by the determinant of the matrix multiplied by adjoint of the. So 1 by determinant of the matrix. 1 by the determinant of the matrix is S square plus 3S plus 2 into the adjoint of the matrix S plus 3 plus 1 minus 2S. So factorize it, S square plus 3S plus 2, right? So what will be the factor? S square plus 3S plus 2. If I find out, so S square plus 3S plus 2, find out the roots, right? So let me find out the roots of this equation. Degree is 2. So A is 1, B is 3, C is 2. So the roots are S equal to minus 1, one root, another root is minus 2. So I can write it in the form of factor S plus 1 into S plus 2. Is it fine? Okay. S plus 1 into S plus 2. So this can be written as S plus 1 into S plus 2, and we will divide all the elements, right? So let me divide all the elements. Let me take it inside. So S plus 3 divided by S plus 1 into S plus 2. So 1 divided by S plus 1 into S plus 2. So minus 2 divided by S plus 1 into S plus 2. S divided by S plus 1 into S plus 2. Okay, this is Si minus A whole inverse. So what we want? Laplace inverse of this quantity. So this should be in the standard form. In order to get the Laplace, this should be in the standard form. So you know how to obtain it by making use of partial fraction expansion. So that I will not be telling. If you are having doubt, if you ask, then only I will tell, right? So just I will write final thing. So let me take the Laplace inverse of Si minus A whole inverse, because I want this, right? Phi of t. So Si minus A whole inverse. So this will give me the state transition matrix phi of t. Phi of t. So let me, by partial fraction expansion, so this we have to make it to standard form. So by making use of partial fraction, this can be written as, so I have the solution directly, I will write it, right? So 2 by S plus 1, this will be 2 by S plus 1 minus 1 by S plus 2, minus 1 by S plus 2. So this is by partial fraction S plus 3 divided by S plus 1 into S plus 2 is equal to A by S plus 1 plus B by S plus 2. Find out the value of A and B. A equal to 2, B equal to minus 1, right? In that way you have to find out. You know it, right? So similarly, this already I have told, right? This same by partial fraction expansion, this also can be done. This one, 1 divided by S plus 1 into, by partial fraction expansion, let us make into standard form. 1 by S plus 1 minus 1 by S plus 2, right? Then similarly this one, so by making use of partial fraction expansion, this we will get it as 2 by S plus 2, 2 by S plus 2 minus 2 by S plus 1. So one and the same, you can write this first, minus 2 by S plus 1 plus 2, one and the same, right? I have interchanged it, right? That's all. Similarly, by partial fraction expansion, this also can be written as, so 2 by S plus 2, 2 by S plus 2, then minus of 1 by S plus 1. Right? Now by making use of partial fraction, for each and every element has been written in the standard form. We know the Laplace inverse of all these quantities. So we will find out phi of t is equal to Laplace inverse of Si minus A whole inverse. It is equal to, what we will get, we will write it. So inverse Laplace transform of 2 by S plus 1, 2 into e to the power of minus t, 2 into e to the power of minus t. Laplace transform of e power minus t is 1 divided by S plus 1, right? So 1 divided by S plus 1 I am getting, minus e to the power of minus 2t. Inverse Laplace transform of this term, right? So it is e to the power of minus. This is one term. Next, coming to the second element, inverse Laplace transform of 1 by S plus 1 is e power minus t. Minus is there. minus e to the power of minus 2t. Next, similarly, the third element 2 into e to the power of minus 2t minus 2, sorry, 2 is there, 2 into e to the power of minus t, because only 1 is there, right? Next, the fourth element 2 into e to the power of minus 2t, then minus e to the power of minus t. This is the state transition matrix, right? So simply we can write it as phi of t, we call it as STM. STM is state transition matrix, right? State transition matrix. Transition matrix, right? This is the final answer. Let me verify it. Yes, it's correct. Yes, it's correct. If any doubts, please unmute yourself and talk to me so that I can clarify your doubts immediately, right? Let us move to the next numerical. Yes, find x of t, right? For the system that is given x dot, it is function of time only. If it is not written x dot of t, function of time only, right? Find x of t for the system. X dot is given, x dot is equal to 0. This is the matrix ax plus bu, right? This is of the form ax plus bu. This is a and this is x and this is b and this is u, right? So x dot, this is x dot is equal to, so this is the state equation, right? So state equation, then initial condition is given x of 0 equal to 1 0, right? And u is the unit step input they are given, unit step input, u is the unit step input, right? Okay, and this is, you can observe here, x dot equal to ax plus bu, ax plus bu. This is the non-homogeneous equation, non-homogeneous equation, right? So the given equation is non-homogeneous equation. And the solution of the non-homogeneous equation we have seen, and I have written the solution here. The solution means solution of this non-homogeneous equation by Laplace transform method, right? So we will see the solution of this non-homogeneous equation by Laplace transform method, LT method, Laplace transform method. And the solution is given by this, x of t is equal to Laplace inverse of, you have to remember this, Laplace inverse of phi of s into x of 0. So this will give me 0 input response because there is no input. It depends only on the state variable x of t. And second term, Laplace inverse of phi of s into b, matrices b into u of s, the input, right? This is 0 state response because it depends only on the input u of s. It does not have any states here. So we call it as 0 state response. This already you know. If it is homogeneous equation, only I will get the first term. X of t is equal to Laplace inverse of in Laplace domain, right? So phi of s into x of 0. In time domain it is x of 0 into e power at. If you remember, x of 0 into e power at for homogeneous equation. In Laplace domain, Laplace inverse of phi of s into x of 0, right? So first we will obtain one by one. Right, we know this, phi of s equal to si minus a whole inverse, it is adjoint of the matrix divided by determinant, this we know, right? So this is the solution of the non-homogeneous equation by Laplace transform method. So first I will obtain 0 input response, then second I will obtain 0 state response, then I will add both of them, then I will get x of t. So we will proceed one by one. So first I will be taking 0 input response, ZIR. So 0 input response, ZIR, I will write ZIR. What is that ZIR? Let me write it, 1 minute. Okay, fine, I will go to the next slide. Okay, here next slide is here. Okay, I was taking previous slide. ZIR, what is that ZIR? Laplace inverse of phi of s into x of 0, phi of s into x of 0, right? Is it fine? Phi of s into x of 0, x of 0 is given, x of 0 is 1 0, right? So first we will multiply phi of s into x of 0. First we have to find out phi of s, right? So call this as equation 1. Only first part we are finding, phi of s into x of 0. Later on we will see the Laplace transform, right? So first phi of s we will find out. Phi of s, what is phi of s? Si minus a. This is nothing but your state transition matrix, right? In Laplace domain, Si minus a whole inverse. Sorry, a. Right? Si minus a whole inverse. So we know this, it is adjoint of the given matrix Si minus a divided by the determinant of the matrix Si minus A. This adjoint. Okay, first we'll find out adjoint. Before that, we'll find out Si minus A. Si minus A. So in order to get the identity matrix, first we have to look at the order of the A matrix. The order of A matrix is 2 cross 2. So the identity matrix should be also 2 cross 2. So S 0 0 S. I am multiplying S for the identity matrix. Identity matrix is 1 0 0 1, right? So I am multiplying S for it, and matrix A I will write. So 0 1 0 minus 2. 0 1 0 minus 2. I hope it is correct. 0 1 0 minus 2. Yes, it's correct. We'll subtract it. S minus 0 is S. So 0 minus 1, it is minus 1. So 0 minus 0 is 0. So S plus 2. Right? Okay. So next we will get the adjoint of the matrix. Adjoint of Si minus A. So the adjoint of the matrix is, so interchange the diagonal elements. So S plus 2 and S, they are interchanged, and change the sign of the other elements. It will become plus 1, and this is 0 as it is. So we got the adjoint. Similarly, find out the determinant of the matrix. Determinant of Si minus A. So determinant of Si minus A is S into S plus 2. Means multiply S square plus 2S. So minus of 0 into 1, right? It will be 0. So minus 0 I will not write. S square, or else, right? Okay, this is fine. Or else I can write it as S into S plus 2. Whichever is convenient, I will make use, right? Okay. Then next, we have adjoint, we have determinant. Next, we will write phi of S, right? Phi of S. So phi of S is the 1 by the determinant of this matrix, 1 by S into S plus 2 into determinant of adjoint of this matrix. That is, adjoint of the matrix is here, this one, S plus 2 plus 1 0 S. So adjoint of the matrix divided by the determinant, right? Okay, we will divide it and write it. So that S plus 2. S plus 2 divided by S into S plus 2. It will get cancelled. S plus 2 will get cancelled. So what I will be getting? 1 by S. Right? S plus 2 will get cancelled. So 1 by S. So next second element, 1 divided by S into S plus 2. Then this third element 0. If I divide it, it will be 0, right? So third element 0. Then third S divided by S into S. SS will get cancelled. So I will be getting 1 by S plus 2. Right? If any mistakes, please let me know. Don't wait till next. Please, if right, this is correct. Phi of S we have calculated. But what we want? Phi of S into X of 0. First we will calculate phi of S into X of 0. Then we will apply Laplace inverse, right? So phi of S into X of 0. Phi of S into X of 0. What is phi of S? Just now we calculated 1 by S 0, 1 by S, and it is 0. Then 1 by S into S plus 2. And fourth element is 1 by S plus 2. So this is phi of S. And what is X of 0? X of 0 is 1 0. 1 0. Please take it correctly. If you take 0 1, everything will go wrong, right? So this is 2 cross 2 matrix, and this is 2 rows, only 1 column. So finally I will be getting 2 cross 1, right? 2 rows and only 1 column. So phi of S into X of 0, let me write it. Phi of S into X of 0, that is equal to what I will be getting. Just I will write it here. So here you know that whatever the matrix I am getting, resultant matrix, it is of the order 2 cross 1. 2 rows will be coming and only 1 column, right? So first row, first column. So first row, first column element. So multiply 1 by S into 1, right? Plus 1 by S plus S into S plus 2 into 0. So this will vanish. So I am getting 1 by S. I hope you are getting. Shall I split it and write? I hope you understood. Multiply first row with first column. 1 by S into 1 plus 1 by S into S plus 2 into 0. So this will vanish. So I am getting 1 by S. Then second row, first column. So 0 into 1, this will vanish, plus 1 by S plus 2 into 0, this will also vanish. So I am getting only this much, right? I hope you are getting. So 2 cross 1 I am getting, right? If any doubts, please ask, right? Matrix multiplication, you know. If you are having doubts, you can ask, no problem, right? So 0 into 1 is 0, plus 1 by S plus 2 into 0 is 0, right? So I am getting this. Then next what I want, Laplace inverse of phi of s into, this means 0 input response finally I want. So let me write it here. 0 input response ZIR is equal to Laplace inverse of phi of s into x of 0. So right, okay, Laplace inverse of let me write it here, no problem. Laplace inverse of this quantity phi of s into x of 0 is nothing but this 1 by s into 0. So what is Laplace inverse of 1 by s? It is ones, right? So Laplace transform of 1 is 1 by s, right? So it is simply 1, right? And Laplace inverse of 0 is 0. So I am getting this. This is ZIR. So let me call this as equation 1. Already I have called it. So I got this, right? So we are getting ZIR. So let me enclose because I have to add later, right? This is ZIR. That is 1 0 I am getting, right? Only 1 0. Okay. Next, ZIR is over. Next, I have to obtain zero state response. ZSR. Laplace inverse of phi of s into b into u of s. Right? We will proceed with the second term. Laplace inverse of, so Laplace, so Z zero state response ZSR is equal to Laplace inverse of phi of s. Let me have a look at it. Phi of s b u of s. Phi of s b u of s. Okay, first we will so call this as equation 2, right? Okay, phi of s, okay, let me call this as equation 2, then call this as 3, right? This as 3. Okay, fine. First we will obtain phi of s into b, then we will multiply with u of s. So phi of s into b, matrix b. What is phi of s? Already we have found out phi of s. Here, this is phi of s, right? We have found out here. Phi of s is 1 by s 0, 1 by s 0. So 1 by s 0 I have written. 1 by s into s plus 2. 1 by s into s plus 2. If I am taking the terms wrong, please correct me, because light switching I may go wrong. So 1 by s into s plus 2, 1 by s plus 2. It's correct, I think, right? Yes. Next, I want matrix B. What is matrix B? Matrix B is 0 1. 0 1, that's all. This is matrix B, 0 1. So 0 1. So this is of the order 2 cross 2, and this is 2 rows and only 1 column. So I'll be getting 2 cross 1 matrix next, right? So let me write it here, what I am getting. So 2 rows, only 1 column, right? Let me, so first row, first column, right? So 1 by s into 0, it will vanish, plus 1 by s into s plus 2 into 1. So that is nothing but 1 by s into s plus 2 I will get. Next, second row, first column. Second row, first column. 0 into 0 is 0. 1 by s plus 2 into 1. So 1 by s plus 2, that's all. Right? So 2 cross 1 matrix I got. This is phi of s into b. This 2 is over. Next, what is u of s? So what they have told, u of s is unit step, right? U is a unit step input. So unit step input means, so what is u of s? If I take a Laplace transform of unit step input, it is 1 by s, right? So input u is unit step input, and the Laplace transform of unit step input is 1 by s, right? So u of s is 1 by s. So u of s is equal to 1 by s, because it is Laplace transform of unit step in. So next we will see phi of s into b into u of s. First we will get it. So Laplace inverse of, so zero state response ZSR. ZSR is equal to Laplace inverse of phi of s into b into u of s. So Laplace inverse of, already we know phi of s into b, right? This is phi of s into b. Let us multiply by with 1 by s, right? Okay. Laplace inverse of, I will multiply 1 by s, so it will become 1 by s square into s plus 2. 1 by s square into s plus 2. So this multiply with s with denominator 1 by s into s plus 2. Is it fine? But I want Laplace inverse. So this should be of the standard form. So Just I will give you the hint. I will not solve you. I will not solve here. Just I will give you the hint how to solve it. So you can see here. Just I will rough work. It is not a rough work actually, but let me. So 1 by uh, s plus 2. Let me write it like this. Into s square. I can write it right. So a by s plus 2 plus bs plus c divided by s square, right? You can, you know how to find out the value of a, b, c and substitute directly. I will write, right? The next, you know this how to do this, right? This one you know. So by partial fraction expansion I can find out a, b, c. Similarly for this I can find out and by making use of partial fraction expansion. So let me go to the next slide. Zero state response is equal to ZSR is equal to Laplace inverse of. So directly I will be writing this. How will be, what I will be getting this one. So by partial fraction expansion, let me have a look at it. What I am getting, I will write that directly. Is it fine? So I am doing the second term anyhow. So what I will be getting, I will write it. Is it fine? So I will write what I am getting. This one, first one. This one, first one. So A, B, C means three terms will be coming. A by something, B by something, C by something, right? So I will be getting three elements. So I will be writing here. So 1 by 4 divided by S plus 2, 1 by 4 divided by S plus 2 minus 1 by 4 divided by S, 1 by 4 divided by S, then plus 1 by 2, 1 by 2 divided by S square. Okay. This is the value of A. A is 1 by 4, B is minus 1 by 4, C is half. You can split this and write Bs divided by S square plus C divided by S square. SS will get cancelled. So B by S. So I am getting this B by S. Right? B by S. I hope you are getting C by S square. So by partial fraction. Next, coming to this term, 1 by S into S plus 2 by partial fraction expansion. In the standard form, I can write it as 1 by 2 divided by S minus 1 by 2 divided by S plus 2. See here, this is only one element only, right? This is 2 cross 1 matrix only, 2 cross 1, 2 rows, only one column, right? Not three columns. This is single element. Next, we will take the Laplace inverse. So I will apply the Laplace inverse of all these terms. Laplace inverse of this first term. So 1 by 4 e to the power of minus 2t. Next, second term minus 1 by 4 into 1. Laplace inverse of 1 by s is 1, right? Plus 1 by 2. Yes, Laplace inverse, this what I will be get into t, because Laplace inverse of t. Laplace inverse of this 1 by s square. Laplace, okay, Laplace transform of t. What is that Laplace transform of t? 1 by s square. You should be knowing it. Laplace transform of t is 1 by s square. I hope you are getting. So general formula is Laplace transform of t power n is equal to I think n factorial divided by s to the power of n plus 1, right? So n is 1 here, right? So 1 factorial is 1. 1 factorial is 1, right? Is it fine? 1 factorial is 1. So s square. So 1 by s square I am getting. So 1 by 2 into t. Is it fine? Next, Laplace inverse of this quantity 1 by 1 by 2 only I will get 1 by 2, because it will be 1, right? So minus 1 by 2 into 1 by s plus 2, Laplace inverse of s plus 2 e to the power of minus 2t. So this is the zero state response I am getting, right? It is 2 cross 1 only. So let me put it in bracket. I have ZS, ZI, zero input response, ZIR and ZSR. So call this equation as 4. So you will add ZSR and ZIS, zero input response. This I should add ZIR plus ZSR, this one. So let me add it so that I will get X of t. X of t equal to zero input response plus the zero state response. So I will, let me write it. What is zero input response? ZIR. ZIR is here 1 0 I am getting, right? 1 0. 1 0 plus, so zero state response. So 1 by 4 e to the power of minus 2t minus 1 by 4, or let me, okay, no problem, minus 1 by 4 plus 1 by or t by 2 plus t by 2 plus t by 2. Next 1 by 2 minus 1 by 2 e to the power of minus 2t. So this is also 2 cross 1 matrix, this is also 2 cross 1 matrix. I can add it. So x of t, it is a vector, right? So if I want to expand it, I can write it as x1 of t, x2 of t, I can write it. It's a vector, right? It has two states corresponding to it, right? You can observe here, right? x1 of t, x2, it has two states, x1, x2, right? So we are finding x, right? X of t. So it is x1 of t and x2 of t. Next, so add 1 plus this term. So 1 plus this term means same thing, I will be getting 1 by 4 e to the power of minus 2t minus t by, sorry, plus t by 2. Let me over, first I will take this minus 1 by 4 constant term, I will be writing at the last. Next, let me take the first term, this one, minus 1 by 2 e to the power of minus 2t plus half. Just I am interchanging, that's all. Is it fine? Okay, this is the x of t, what we have found out, right? Hence the solution, x of t we have found out. Any doubts in this, you can ask. Any doubts are there? You can unmute yourself and talk to me and you can ask it. I hope, if you are not asking, I hope you understood, and I will continue with the next topic, right? So only thing is, if you only have to remember this much, if you remember this much, you can do blindly, right? Only matrix multiplication and additions and subtractions will be there, right? The only thing you have to remember this. Okay, this is over. Next, this one, the same thing. I hope you can do this, right? I will leave it to you people, right? But if I have the answer, I will give you. You do it and send me the answer. I will check it, right? Because the same thing what we have done previously, it is same, right? But let me check it. It is 3 cross 3 or what? No, it is fine. So x dot of t equal to ax. This is ax plus bu. So this is x dot equal to ax plus bu. Is it fine? So x of 0, initial condition is given. So this is non-homogeneous equation, same as previous problem. This is non-homogeneous equation, right? So non-homogeneous equation. So find the unit step response of x of 0. X of 0 is 1 1 here, right? So for solution of non-homogeneous equation, we know it. X of t equal to 0 input response plus 0 state response. 0 input response is Laplace inverse of phi of s into x of 0, and 0 state response is Laplace inverse of phi of s b u of s, b into u of s. So you know how to find out. So you solve it. Here find the unit step response means it is find x of t, one and the same. Find unit step response, or it can be asked like this also, find x of t. This is x of t, right? So one and the same. Find x of t or find the unit step response when x of 0 equal to 1 1. Same, one and the same, right? So you solve it. I am leaving this to you people, and solution is here anyhow. If you have having doubt, you can refer this solution, right? Go through this. First they are getting 0 input response, right? 0 input response, this one. Then they are getting 0 state response here. This is 0 state response they are getting. Then they are adding 0 input response plus 0 state response, and this is x of t, final vector. This is the answer. You can verify. You do it by yourself. If any doubts, you can get back to me, right? The solution I have shown you, right? Just I'll go slowly, just so that it will be recorded in the video, right? This is the step by step, right? You can have a look at it, or you can take the screenshot later. Yes. Okay, fine. Next, this is the last topic in this chapter. I hope you will solve that previous numerical whatever I assigned, and please send me the WhatsApp to my personal number, the solution, whatever you have done. The solution I have given, but still you do it and send me, right? Okay. The next, last topic in this chapter, transfer function from state model. How to derive the transfer function from the state model. Okay. What is state model? We already know, and this is the multiple input, multiple output system. This diagram you know. It has m number of inputs, p number of outputs, and n number of state variables, right? Okay. This diagram you know. So state model means it has both state equation as well as output equation. This is the state equation. We know that this is state equation. x dot of t equal to ax plus bu, and output equation, this is output equation, y of t equal to cx plus du, right? This is output equation. Is it fine? Okay. So first write the state equation and output equation, because from state model, first write down the state model. This is the state model, right? Consider the standard state model having both the state equation and output equation we have written, right? Fine. Then take Laplace transform of both state equation as well as output equation. Take Laplace transform of this state equation. Laplace transform of x dot of t is equal to s into x of s minus x of 0. Right, this is initial condition. Usually we used to neglect the initial condition, but in the transfer function we have to neglect it, right? We will neglect it later. So s into x of s minus x of 0. This is Laplace transform of x dot of t. It is equal to a into x of s plus b into u of s. The same thing has been written, a into x of s plus b into u of s. Then take the Laplace transform of the output equation. So y of t means y of s is equal to c into x of s plus d into u of s. So this is the Laplace transform of output equation. So if I want transfer function, it should be the Laplace transform of the output. Output means here y of s, and Laplace transform of the input, here it is u of s. Assuming initial conditions to be 0, right? We will assume initial conditions to be 0. That is the definition of transfer function. We know it. Y of s divided by u of s, the Laplace transform of the output to the Laplace transform of the input, assuming initial conditions to be 0, right? Okay. So we will try to obtain y of s by u of s. So already I have y of s equation. Call this as, they have called equation. So you can call by equation 1, 2, 3, 4, whatever it is. Leave it, right? So they have called this equation 1, 2, 3, 4, whatever it is, right? The next y of s is fine. So first we will find out x of s, right? From the input equation. We have stopped here, right? So we will continue with this. So s into x of s. In transfer function we will neglect the initial condition, so we will not take this. So we will neglect this. So only s into x of s, right? S into x of s. Remaining thing I will write as it is, a into x of s plus b into u of s. Is it fine? So already I have y of s equation. Next I want u of s. So we will try to get u of s from this equation. So s into x of s, take this a this side. So minus a into x of s, b into u of s. From this I will be getting u of s, right? So we will proceed slowly. So yes, s into x of s minus a into. So this is a is a matrix, right? So s is an operator. So I should make this also matrix of the same order as that of a. So let me take the identity matrix. Let me add I for this identity matrix I. So si into x of s. If I add identity matrix, there is no harm in it, right? So si into x of s minus a into x of s, that is equal to b into u of s. So take x of s common from both. So si minus a I will get, that is equal to b into u of s. Then I will be getting u of s. Let me write it. Same equation has been written here. Si minus a into, right? Then multiply both sides by si minus a whole inverse. So we will multiply both sides by si minus a whole inverse. So multiply. So si minus a whole inverse into b into u of s. We have written here. Multiply. Then a into a inverse is 1. So this will become 1. Right? Only I am left out with only x of s. This will become 1. Right? This is 1. A into a inverse is 1. Right? So si minus a whole inverse into si minus a is 1. X of s is equal to si minus a whole inverse into b into u of s. This is x of s, I got it, right? Let me substitute this value of x of s in this equation, y of s. So y of s equal to c into, what is x of s? We will substitute here, x of s, right? We will substitute for this. So c x of s plus d u of s. So y of s is equal to c x of s. What is x of s? This one. So we have written here, we have substituted x of s. Right? This is c x of s. This is x of s plus d into u of s. Is it fine? Next, c into si minus a plus b. So u of s is taken common, right? From this u of s, take common u of s. So it is taken out. You write it. So finally, the transfer function is ratio of y of s by u of s. So y of s divided by u of s. Take divided by u of s, right? So y of s by u of s is equal to c into si minus a whole inverse plus b into d. I remember like this. You can remember this transfer function equation very easily. C inverse b. I will write it like this, C inverse B. C inverse B plus D. Inverse means what? Si minus a whole inverse. You just remember this. C inverse B plus D is the transfer function equation. Transfer function equation is equal to C inverse B plus D. C inverse means this one, Si minus a whole inverse. C inverse B plus D. Right? So the transfer function depends on the matrices C, B, D and the inverse function Si minus a whole inverse. And we know how to find out this inverse Si minus a whole adjoint divided by determinant, right? Okay, next we'll solve few numericals and we will wind up this chapter. There is no derivation, just you should be knowing it, right? However, this is a general thing, how to obtain transfer function from the given state model. One more thing you have to observe here, one key point or note, the state model is not unique, but the transfer function should be same, whatever may be the state model, right? The state model of a system is not unique, but the transfer function obtained from any state model, it should be unique. Transfer function should be same, it should not be different, right? I hope you understood this. Next, what is characteristic equation? In this just we'll try to understand. Already we know the denominator of the transfer function will give me the characteristic equation and they are nothing but the closed loop poles of the given system, right? Right, they will get the stability. Here in this, observe this characteristic C inverse B plus D. What is this? Inverse means adjoint of this matrix divided by determinant. Let me write it here. Let me substitute this here. Adjoint of the matrix divided by determinant means the denominator will be Si minus a whole inverse. In the transfer function, the denominator is this. So this is the denominator in the transfer function, right? Si minus a whole. So this will give me the characteristic equation. So here the characteristic equation of this transfer function is Si minus a and equate that to 0. That is the characteristic equation. Here we will not call it as a characteristic, right? Here that is the characteristic equation here, right? So it is of determinant of Si minus a equal to 0. And the roots of this equation Si minus a are nothing but the eigenvalues of the matrix and we represent it by lambda, right? This term lambda. So we will not see further. We will stop here only, right? We will not worry much. But you should be knowing what is characteristic equation, right? I hope we'll proceed. We will not solve any numerical, but you should be knowing it. That's all. Next, we'll solve one or two numericals based on this and we'll wind up this topic. Is it fine? Yes. If any doubts at any moment, please unmute yourself and talk to me so that I can clarify your doubts. Is it fine? Okay. Okay. We'll take up this numerical. Find the transfer function for the state model given as this is given. X dot is equal to this once again the same thing, right? So this is of the form AX plus BU. AX plus BU. This is the state equation. X dot equal to. So x dot equal to ax plus, this is the state equation and this is the output equation. So y equal to cx plus d, cx plus it is not there here, but let me write it, cx plus du, but d and u are not given here. It is 0, d is 0, u is also, input is not given, right? So y is equal to cx, this is the output equation, cx plus d, these two equations, this is the state equation and this is output equation. So let me calculate the transfer function. So the transfer function is equal to, it is the ratio of output y of s and the ratio of input, that is u of s. What is the, how to remember, I told C inverse B plus D, right? C inverse means Si minus A whole inverse. C inverse B plus D. I hope you got it. How to remember? The transfer function is C inverse B plus D. You can have a cross verification, C inverse B plus D. C inverse B plus D. It's correct. C inverse B plus D. Right? This is the transfer. So, in this we have to identify which is matrix C, which is matrix B, which is matrix D. And we have to obtain Si minus a whole inverse. Then we will multiply accordingly and we will get the transfer function. So, first we will find out Si minus, call this as equation 1. Right? So, first we will get Si minus a whole inverse. Right? We know how to obtain it. So, get Si minus a first. So I have written which is A, B, C, D. I have identified. This is A matrix, this is B matrix, this is C matrix, this one, and D matrix is 0. Right? D matrix is 0. So A matrix is of order 2 cross 2. So at the identity matrix, what I should take, it should be 2 cross 2. So let me write S 0, 0 S. I am multiplying S with identity matrix 1 0 0 1. So I will get this Si. This is Si minus A. What is A? Minus 5 minus 1. 3 minus 1. So subtract this 2. So S plus 5. S plus 5. Because minus of minus is plus. 0 plus 1. It is 1. Then 0 minus 3. It is minus 3. Then S plus 1. Minus of minus is S plus 1. It's correct, right? If I am making mistakes, don't wait, please correct me immediately, right? Next, I want Si minus a whole inverse. Si minus a whole inverse. How to get Si minus a whole inverse? It is adjoint of the matrix Si minus A divided by the determinant of the matrix Si minus A. So first we'll find out adjoint. So the adjoint of the matrix Si minus A is equal to, so this is Si minus A. How to interchange the diagonal elements? So S plus 1 will come here, S plus 5 will go here. So interchange the diagonal elements over, then change the sign of the other elements. Change the sign. So plus 1 means minus 1, it is minus 3 means it is plus 3. We should be very careful. Is it fine? Next, adjoint is over. Next, determinant of Si minus A. Determinant of Si minus A. So find out the determinant. This is Si minus A. S plus 5 into S plus 1. S plus 5 into S plus 1 into minus of 3, 1 into minus 3. Minus to minus plus it will become, then it is 3. Is it fine? 3 1 ja 3. Minus 3 means minus to minus it will become plus. So determinant, let me expand it. Determinant of Si minus A is equal to, let me multiply. S into S is S square plus S into 1 is S plus 5 into S is 5S, then 5 into 1 5, then remaining is 3 plus 3. So what I will be getting? S square, so this 5S plus S 6S plus 5 plus 1 6S plus 5 plus 3 is 8. Is it correct? Next we will find out Si minus a whole inverse. Si minus a whole inverse is 1 by the determinant multiplied by adjoint of the matrix. 1 by determinant. So let me write 1 by determinant. 1 by determinant. What I am getting? S square plus 6S plus 8 multiplied by adjoint of the matrix. Here it is adjoint of the matrix. S plus 1 minus 1. S plus 1. Second element is minus 1. Next 3. S plus 5. 3 is one element. S plus 5 is another element. I hope it's correct, right? Yes. Okay. Just we'll try to find out the roots and we'll try to simplify it this side. So S square plus 6S plus 8. So let me use the calculator. Go to the equation. So go to equation. So degree is 2. So A is 1. B is 6. C is 8. So roots are S equal to minus 2 and another root is minus 4. So I can write it as S plus 2 into, 1 minute, let me, okay, fine. I can write it as S plus 2 into S plus 4. Okay, let me divide it and write it here. So Si minus a whole inverse equal to S plus 1 divided by S plus 2 into S plus 4. I am taking inside this, divide it. So S plus 2 into S plus 4. Next, minus 1 divided by S plus 2 into S plus 4. Next, 3 divided by S plus 2 into S plus 4. Next, S plus 5 divided by S plus 2 into S plus 4. So this is Si minus a whole inverse. And this is of the order 2 cross 2. 2 rows, 2 columns, right? Okay, what we have found out only this much. Then we have to multiply with matrix C, then with B, right? Whatever it is, right? So first we'll multiply with C, or else we'll find out C, Si minus A, and we'll multiply all the three. First we'll C into this, right? So C into Si minus A whole inverse. C into Si minus A whole inverse. I am doing this part, C into Si minus A whole inverse. What is C matrix? C matrix is 1, 2, this one. You can observe here. This one is C matrix, 1, 2, right? Let me write it, 1, 2. Only one row, 2 columns. Then Si minus A whole inverse is this. right? Okay, s plus 1 divided by s plus 2 into s plus 4 minus 1 divided by s plus 2 into s plus 4, 3 divided by, this is 3, okay, let me rewrite it, 3 divided by s plus 2 into s plus 4, s plus 5 divided by s plus 2 into s plus 4, okay. So this is the matrix. How many rows are there? Only one row, two columns. Here this is 2 cross 2. So finally what I will be getting? 1 cross 2 matrix. Only one row, two columns, right? Next I will be getting the same thing. Let me write it. So C into Si minus A whole inverse. I am doing this. So what is the final matrix I am getting? Only one row but two columns, right? So multiply first row with first column. First row, first column, right? So first row, first column means 1 into s plus 1, this one, 1 into this quantity, then plus 2 into this quantity, right? I hope you are getting 1 into this quantity, 2 into this quantity. So let me write it. So 1 into s plus 1. So s plus 1 divided by 1 into this means I am getting the same thing, s plus 2 into s plus 4 plus 2 into this, plus 2 into this first column, first row, first column, right? 2 into 3, 6. So plus 6 divided by, because 2 into 3 is 6, right? Divided by s plus 2 into s plus 4. Oh, I could have done one thing. This I could have kept outside. That would be very easy for me, right? So I am making myself complex here. Okay, let it be. Anyhow, written, I will continue. You better take s plus 2, s plus 4 outside and keep it. Later on, you can multiply. I have made complicated here. Let it be, no problem. I will continue with this only. So next, this is over. 1 minute. Yes. This is first element. Second element will be coming here. This is first element. Next, second element I will write, because only one row, two columns, right? So first row, first column is over. First row, second column. First row, second row, 1 into this quantity. So I will get minus 1 divided by s plus 2 into s plus 4. Then 2 into this quantity, 2 into s plus 5 plus 2 into s plus 5 divided by s plus 2 into s plus 4. You don't make this mistake. Better you take this common outside. That would be better, so that it will be simplified. So I am getting the matrix of 1 cross 2. 1 row, 2 columns. Is it fine? So still there is time. I can do it, I think. Yes. Let me take it outside and write it. 1 by s plus 2 into s plus 4. Reverse engineering I am doing. Okay. Yes, this is, I have taken this out. S plus 1 plus 6 means s plus 7. Yes, it is correct. Yes, if I take LCM, right? So s plus 1 plus 6 plus 1, 7, s plus 1, first element. Second element, this, we will take this outside. So what I will be getting? Minus 1, let me write somewhere outside, so rough. Let me change the ink color. So minus 1 plus 2s plus 2 into 5, 10. So I will write, I will change the ink color. So second element, what I will be getting? 2s, 10 minus 1 is 9. I hope it's correct. Okay, this is C into Si minus A whole inverse. It is better that I could have done C into B first, because C and B, it is very easy, right? C into B, then I could have taken with this. Okay, anyhow, I done. You do it whatever the way you want. C into Si minus A whole inverse into what? Into B. So C into Si minus A whole inverse, I am getting this. Let me write it. 1 by S plus 2 into S plus 4. I will keep it outside only, right? Later on I will multiply. So S plus 7 into 2S plus 9 into what is B matrix? B matrix is 2, 5. Observe, right? 2 and 5. 2, 5. 2, 5. So this is 1 row, 2 columns. This is 2 rows, 1 column. So I will be getting 1 cross 1. Right? They are of not same order. So I will be getting 1 cross 1 matrix. So let me check it what I will be getting. 1 divided by S plus 2 into S plus 4. So 1 cross means only 1 row, 1 column. Only one element I will be getting. Only 1 row, 1 column. Right? So multiply first row with first column. 2 into S plus 7. Let me multiply directly. Right? First row, first column. Right? 2 into S plus means 2S plus 2 7 are 14. Plus multiply this first row first column, right? So 5 into this, so this is 5 to the 10s plus 5 is 40, 5 9 is 45. It's correct, right? So what I will be getting, let me write it, S plus 2 into S plus 4. So 10s plus 2s, it is 12s plus 45 plus 14, 5 4 9, 4 plus 1 5, 59. I hope it's correct. So this is C into Si minus a whole inverse into B. This one. First part is over. Next plus D. I have to add with D. Then I will get transfer function. So transfer function is equal to, oh, I don't have any other slide. So, okay, let me do it here. So, a problem continued in next slide. Okay, continuation of previous problem. Continuation of previous problem. So, don't get confused. Transfer function equal to C inverse Si minus A whole inverse C inverse B plus D, right? Okay, write it. So transfer function is equal to C inverse B. What is C inverse B? It is 1 by S plus 2, 1 by S plus 2 into S plus 4 into 12S plus 59, 12S plus 59 plus D. What is D? D is 0 here. So D, it is not there means it is 0, right? So D is 0, right? So D is 0. So D is 0. So element is 0. No need. So find, this is the final transfer. Final transfer function is 12S plus 59 divided by S plus 2 into S plus 4. You can multiply and write it, or else you can keep it like this only. 12S plus 59 divided by, let me multiply, S into S is S square plus S into 4 is 4S plus 2 into S is 2S plus 2 into 4, 4 to 8, 2 4 8. So what I am getting, S square plus 4 plus 2 6S plus 8. So this is the transfer function. I hope you are getting. Let me verify the answer. 12S plus 59 divided by S square plus 6S plus 8. Right, 12S plus 59. They have not multiplied. S plus 2 into S plus 4. They have kept in this form only. This is, they have kept. Right, this is the transfer function. Right. Okay, I hope you understood. This completes this chapter, but I have one more problem. See here, matrix is given A, B, C. I think this is the last one. I think I don't have any other. I have this problem also, right? Okay, let me solve this problem and give this as assignment for you people. Let me solve this problem. Let me solve this. Okay, this one, the solution. Have a look at it. I'll give the hint for this, because anyhow you solved transfer, how to obtain transfer function we know. So find the transfer function of, for the state model. Solution is here only. So this is given, x dot equal to ax plus bu, right? So x dot equal to ax plus bu. This is state equation. Then y equal to cx plus du. So here d is 0, u is 0, right? D is not there, d is 0. So we have identified this is matrix A, and this is matrix B, and this is matrix C. Matrix D is 0, right? Matrix D is 0. It is single, right? Only one input means it will be 0, right? Okay, we know the transfer function equation is equal to y of s by u of s, that is equal to C inverse B plus D. C equation is 1 0 here, C is here, right? 1 0 they have written. Then Si minus A whole inverse, how to find out, you know? So find out Si minus A and Si minus A whole inverse. After finding this we will get. So Si minus A whole inverse Si minus A whole inverse means this is Si minus A. Inverse we have to find out still. And B, what is B? You can do in this way also, or else you can do this first separately and this first separately, later on this. So you can do it separately, or else do at a time, it's left to you. And B, what is B? B is 0, 2, they have written. D is 0, right? Next 1, 0. And the inverse of this matrix. So if I find out the inverse, you know how to find out Si minus A, they have done this, right? And this is 0, 2, they have written 0, leave it. So this quantity as it is, and you know how to multiply. Finally, you will get the transfer function as transfer function is equal to, you do it, you try it. If any doubts, you let me know it, because I want to do one more problem next. This is simple, right? Next, this is the transfer function you will be getting. Next, I'll take up this, and next I will give it as homework. This also you take it as homework only, but solution is here only, right? This is solution. Already you have solution also for this. Okay, matrix A is given, matrix B is given, matrix C is given. So find the transfer function of the given state model they are asking, right? So solution. So the transfer function equal to C inverse B plus D. D is not given means it is 0. It is not given here, right? D is 0 if it is not given. They should give also, right? D is 0. Is it fine? Let me give it. So transfer function is equal to C inverse B. Inverse means the Si minus A whole inverse. C inverse B plus D. Right? Okay. The next. Oh, okay. Let me observe the next problem. D is given or not here. X dot. This is X equal to AX plus BU. C and D are not given. C and D are not given. Right. C is given. D is not given here. D is 0. Okay. Fine. I will give the hint and leave it. That problem. Okay. D is 0 here. Okay. Fine. First we will do this Si minus A whole inverse separately, right? Si minus A whole inverse. Sorry, Si minus A whole inverse. It is nothing but the adjoint of the matrix Si minus A divided by the determinant of the matrix Si minus A. Right? So first we will find out Si minus A. So what is matrix A? It is of 3 cross 3, 3 rows, 3 columns. So I should take the identity matrix also 3 cross 3 and multiply with S. So let me, so it is 3 cross 3 identity matrix means what is I? I is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. This is 3 cross 3, same as A, right? So multiply S for it. So S 0, 0, 0, S 0, 0, 0, S. Is it fine? Si minus A. What is matrix A? We will write it 0, 1, 0, 0, 0, 1, minus 1, minus 2, minus 3. So we will get Si minus A here. Subtract corresponding elements. So S minus 0 is S. So 0 minus 1. 0 corresponding element 0 minus 1 minus 1, 0 minus 0 0, then 0 minus 0 0, then S minus 0 is S, 0 minus 1 minus 1. So 0 minus of minus means 0 plus, it is 1 plus 1. So 0 minus of minus 2 means plus 2, it is 2. So S minus of minus is S plus 3. I hope you are getting. This is Si minus A. So, for this problem I have to, because I don't know how to find out adjoint of 3 cross 3 matrix. Can you help me out, anyone? How to find out adjoint of this 3 cross 3 matrix? Anyone? Adjoint of 3 cross 3 matrix, or else I will stop here only, or else I will take in the next class. Maybe in the evening after finding out, or else in the afternoon I will take. I will stop here only. I will take in the afternoon. I will stop recording here.